Alright, Chapter 9, Study Guide, Quadratic Functions. Here we go. Match the description and words to the parabola given. The axis of symmetry is the y-axis. That would be A right here, right down the middle. Is the axis of symmetry, happens to be the y-axis, so it's going to be A. A quadratic that has no solutions. Again, the word solutions is another word for x-intercepts. Okay? And so, which ones have no x-intercepts? Well, that one does, that one does, that one does. A, again, no x-intercepts. A quadratic that has a discriminant equal to 0. If it's a 0 discriminant, it means it only has one solution. And D, it hits the x-axis at one spot only. So that has just one solution right there. So that's going to be D. A vertex at -2, -3, well, that's going to be B, -2, -3. An A value that is negative, every graph is going up except for C is going down, so C is our negative A value. And a quadratic with a negative discriminant, if you have a negative discriminant, it means you have no solution, which is A. So A is our popular choice for 1 through 6. Okay. Given the quadratic function, find the axis of symmetry. Okay, to find this, we're going to do negative b over 2a. And we have our a value of 2, b value of 0, and c value of -2. The b value should be in front of the x term. There is no x term, so it's 0. So we get 0 over 2 times 2, which is just 0. Okay. Well, that's part of our vertex, which is 0, comma something, but this is the x value, so it means the x value is x equals 0, also known as the y-axis. Okay. The vertex, we have 0 now, so we can go ahead and plug this into our xy table, and we get 2x squared minus 2. Plug in 0, you're going to get 2 times 0 squared minus 2. That's just 0 minus 2, which is minus 2. So we get 0, -2. Is this a min or a max? Well, since the a value is positive, it's going to be going upward forever. So that means this vertex down here is a minimum. Solve for the solutions of the quadratic. Well, that would be when y equals 0. So y equals 0, 2x squared minus 2. We can go ahead and add the 2 over, which gives us 2 equals 2x squared, divide by 2, and 1 equals x squared, and take the square root. So we get x equals plus or minus 1. So the solutions are going to be 1, 0, and -1, 0. So we solve using square roots, and then graph it. Well, our vertex is at 0, -2, and then we have 1 and -1. We need one additional point, so I'm going to actually plug in 2 up here to our chart from before. So we plug into 2 squared minus 2. That's going to be 4 times 2, which is 8, minus 2, which is 6. So we're going to get 2, 6. X equals 0 is my line of symmetry, so I go to my line of symmetry, and then 2 over. And there we go. There's my graph. And that's my minimum. Given the quadratic, find the axis of symmetry. So same thing, we're going to do negative b over 2a. Here we have a equals 1, b equals 8, and c equals 12. So we're going to have -8 over 2 times 1, which is -4. So x equals -4. We can actually go straight to our graph and go to -4, and we can put in our axis of symmetry. We already know that's where it's going to be. Solve for the vertex. Well, I know the vertex is going to have that -4. So we can go ahead and set up our chart, x squared plus 8x plus 12, plugging in -4. Make sure you use parentheses here, very important. Otherwise we'll make a mistake. -4 squared is 16, times 8 times -4 is -32, plus 12. And I'm going to double check this using my calculator so I don't make a mistake. And I get -4. So -4, -4 is where my vertex is. So I'm actually going to go straight down and put my vertex in at -4, -4. There's my vertex. Does it have a min or a max? Well, again, my a value is positive, so it's going to be going up, which means it has a minimum because it goes up forever. Solve for the solutions. So we're going to do 0 equals x squared plus 8x plus 12. This looks like it's a standard one that we could factor, so I could think to myself what two numbers multiply 12 and add to 8. And let's see, we got 1 and 12, that doesn't do it. 2 and 6, that will work. So you get x plus 2 and x plus 6. Then we have to use the zero product property to actually solve for it. So we get x plus 2 equals 0 and x plus 6 equals 0. That's going to become x equals -2 and x equals -6. So we're going to get -2 comma 0 and -6 comma 0. And we can graph those, -2 comma 0 and -6. Notice they're equidistant to the line of symmetry, or axis of symmetry. And then to graph, we just need one more additional point. If we plug in -3, we should be able to do it. I don't really have a lot of space up there, so I'm going to rewrite my little chart. And we're going to plug in -3 squared plus 8 times -3 plus 12. So that's going to become 9 minus 8 times -3 is going to be a -24 plus 12. So 9 minus 24 plus 12 is going to give me a -3. So there we go right there, which means I'm going to have a point right over there. And there's my graph. Given the quadratic, solve for the axis of symmetry, the vertex, and the zeros. Okay. Again, my a value is -1, b value is 0, and c value is 1. So we have to do the -b over 2a. Well, that's going to be 0 over 2 times a -1. Doesn't matter, it's 0. So my axis of symmetry is x equals 0. And then my vertex is going to be 0 comma something. So we'll write our x and y chart. Plug in 0. That's just going to make it 1. So my vertex at 0 comma 1. And then we want to solve for the zeros. This is setting the whole equation equal to 0. And we can do that quickly. So we set y equal to 0, that's going to give me my zeros. I can subtract the 1 over, and then I can divide a -1, so I get 1 equals x squared, take the square root, I get x equals plus or minus 1, which means I'm going to get 1 comma 0, remember the y was 0, and I get -1 comma 0. Given the quadratic function, solve for the axis of symmetry, vertex, and zeros. Wow, they really want us to get this down, which is good. A is 1, B is 4, and C is 0. So the axis of symmetry we'll find using -b over 2a. That's going to be -4 over 2 times the a value, which is 1, which is -2, so x equals -2. The vertex then is -2 comma something, so we're going to plug it into my x and y table. So we get -2 squared plus 4 times -2. That's going to become 4 plus a -8, which gives me -4. And then my zeros. I'm going to set this equal to 0 and solve. So 0 equals x squared plus 4x. I can factor an x out using GCF. Always a good method when we don't have a c value. And then we can use the zero product property. And we get x equals 0 and x plus 4 equals 0, which that's just 0, and that's going to subtract, and we get x equals -4. So we get 0 comma 0, and then we also get -4 comma 0. Identify the vertex. The vertex is at -6, -5. The axis of symmetry goes right through -6, so it's going to be x equals -6. The roots are at -4 and -8, so we get -4 comma 0 and -8 comma 0. The domain, it goes on outward forever, so it's going to be all real numbers. identify the range. It starts at -5 and then goes up forever. So y is going to be greater than or equal to -5. It is a minimum. That's the smallest value. It goes on up forever. And is a positive. A is positive because the graph goes up. Solve the quadratic function using square roots. So I'm going to just add the 12 over. Divide by 3. And then we can take the square root, which will give us x equals plus or minus 2. Remember to always do plus or minus 2. Always find the plus or minus if you're doing square root. Factoring, we're going to go ahead and factor what multiplies to 6 but adds to 7. That's going to be 1 and 6. So you get x plus 1 and x plus 6 equals 0. And we're going to do zero product property. X plus 1 equals 0. X plus 6 equals 0. So we get x equals -1 and x equals -6. This one's also a factoring, so we're going to add the 75 over. I'm going to factor a 3 out, which gives me x squared minus 10 plus 25. I could divide both sides by 3 and then just basically eliminate it, which is fine. But this factors 25 and -10 would be -5, -5. So I get x minus 5 and x minus 5 equals 0. Zero product property. I just have to set these ones equal to 0. But they're the exact same, so I just really have to do it only once. So that's a rare one where you only have one solution and no more. Okay. Solve the quadratic equation. We have a, b, and c. A is 4, b is -5, and c is -6. I'm going to write the equation out, but with space. The negative boy couldn't decide if you want to go to the radical part. He didn't want a b squared, miss out on the 4 awesome cacti. The whole thing was over at 2 a.m. So again, b is going to go in here, -5, -5, a, and c, and a. So we're going to get -5 becomes a +5, plus or minus the square root. -5 squared is 25. 4 times 4 times 6 is 96. There's two negatives. We're going to add them all over 8. So 25 plus 96 is 5 plus or minus the square root of 121 over 8. 121 is a perfect square, so we can actually solve that. This is going to become 5 plus 11 over 8 and 5 minus 11 over 8. So to evaluate 5 plus 11, again, the square root of 121 is 11. 5 plus 11 is 16 divided by 8, which gives me 2. 5 minus 11 is a -6 over 8, which will give me -6 over 8. Or we could reduce that to -3 over 4. Solve by complete the square. So we're going to have to subtract the 4 over. We get x squared plus 6x blank equals -4 and blank. We got to be careful not to forget how to do this. This is b divided by 2 squared, not -b divided by 2a, different. We get 6 divided by 2 squared, which is going to be 3 squared, which is going to give me 9. But whatever I add to one side, I have to add the other. This breaks down into a squared binomial where 3 times 3 makes 9 and 3 plus 3 makes 6. And this equals 5. Take the square root of both sides, and we get x plus 3 equals plus or minus the square root of 5. Then we subtract the 3 over. And we get our final value. -3 plus or minus square root of 5. Square root of 5 is not a perfect square, so I can't go any further. Number 17 we did in class. I did this one using a method of my choice, which was complete the square. Now I wouldn't recommend doing complete the square for this one. I would do probably quadratic formula, but I did one with quadratic formula right underneath it. So that one was done quadratic formula, which we just did. We got a negative underneath the square root, which is not possible to take the square root of, so we said no solution. Number 19, I solved by square roots. Since I only had an x squared, I moved the 14 over. I divided by 4, and then I took the square root, reminding myself to do plus or minus. This one, any method of my choice. I noticed that right away it's divisible by 2, so I'm going to go ahead and try to see if I can do this without doing quadratic formula or anything like that. So 16 and negative 8, I'm trying to think of two numbers that multiply to 16 but add to a negative 8. I think I've got my answer of negative 4, x minus 4, and x minus 4 equals 0. So zero product property, I only have to do one of these because they're going to be the same, and we get x equals 4. And solve the quadratic function using the method of your choice. Now I might be going crazy, but I believe that's the exact same problem, so that's a repeat. Okay, I did do number 22, and it's putting in a vertex form, so you have to know the vertex form. So first thing is we want to find the vertex. So we use negative b over 2a, so I got negative 8 with a negative out front, so it makes it positive 8, and then 2 times a, which is 4, so we get 1. And then plugging in 1 for x will give us the y value of negative 1, so we get our vertex here. So all I did was just plug into the equation. So instead of h, I'm going to plug in 1. The negative there is from the equation, plus whatever k is. Well, k is negative 1, so I'm going to add negative 1. Okay? And then a, what's the a value? Well, the a value is 4, so we just put 4 in the front. That's vertex formula. Number 23 is just how discriminant works. It's the negative b squared minus 4ac. If it's greater than 0, we have 2 solutions. Equal to 0, we have 1. And less than, we have none. The main thing, we talked about this one in class. I'll show you how to do this one. We talked about Tyler being our soccer ball instead. Sorry about that, Tyler. But did your soccer ball travel higher? So distance or height, we're looking at vertex. The height is the y value because it's written right there as the y, and the d was kind of like the x value. And so we found the vertex of 3 for the x value from this, and then we plugged in and got 144. So we kicked 144 versus 100 feet the friend did. When you're trying to find when it hits the ground, what you're really looking for is roots, intercepts, zeros, solutions. So we're going to solve this by setting equal to 0. I used GCF, zero product property. We came up with 0 and 6, so I'm assuming he was on the ground, kicked him, went up in the air, and then after 6 seconds, he's back on the ground. And that's it. Good luck.